Hello everyone, good afternoon. Dear authors and invited guests, I welcome you all to the technical session 6E. Myself Siddesh Mogal and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and Gujarat Scholastic LLP, it is my great pleasure to welcome you all to the fourth World Conference on Information System for Business Management ISBM 2025 Bangkok, Thailand. The fourth edition of the conference is being organized in hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like you to introduce the chair of this session, Dr. Firdos Sheikh. Dr. Firdos Sheikh is an associate professor and deputy head of the Department of Computer Science and Engineering at Purnima University, Jaipur. He has over 15 years of experience in teaching, research, development, and academic administration. He also serves as a book editor as an editorial board member of the Leading Journal. Sir, do you have any opening remarks for the participants? Firdaus sir?
Sir, 1 minute.
Yeah, sure, sir.
Okay, now good.
Okay. So can we move further, sir? Yeah, you're visible and audible also.
Okay. So, very good afternoon, all of you. This is Firdaus Sheikh, Deputy HOD in Purnima University, Jaipur, Rajasthan, from India. So, I warm welcome to all August virtually presented in the fourth World Conference on Information System for Business Management, which is held on 24 to 26 September. So, I warm welcome to all this August present as a session chair. So today already sir told you that today we have the 10 presentation. So firstly, I would like to thanks to Dr. Amit sir for inviting me as a session chair in the beautiful World Conference on Information System for Business Management. So thank you so much, sir, for invited me of such a beautiful workshop. So today we have a 10 presentation with us, which will be delivered virtually. So already I think, sir, that time the voice is not coming to me, so I just revised the suggestion to the all presenter. In total, there will be a 10 papers presented in this session, which is 120 minutes of the session, and 10 minutes are scheduled for the each author to present their paper. So this is the time constraint. So please be finished within the time limit. So within the 10 minutes, you have to finish your presentation, and followed by the some question and answer for 1 and 2 minutes. So this is from my side, sir. You can proceed.
Thank you, sir. So moving further, we'll start with the presentations. So first we have Trilok Kola. He is presenting adaptive ambient intelligence machine learning model for context prediction in ambiguous system. Trilok, are you there?
Yeah, sir, I'm there.
Yeah. Trilok, can you rename your Zoom name so that we can track you? And you can start your presentation. Yeah, thank you.
Can I start, sir?
Yeah, you can start. Yeah, you can share your screen now.
Audible, sir, here. My
Yeah. Your screen is visible and you're audible properly. You can start.
Its title is Adaptive Ambient Intelligence Machine Learning Models for Context Prediction in Ubiquitous Systems.
Trilok, can you just present your presentation in presentation mode? Yeah.
Now it's okay, sir.
Yeah, thank you. You can start.
Yes. Now, abstractly, this paper mainly proposes a machine learning framework for predicting user context in ubiquitous environments using like multi-sensor data such as temperature, light, sound, motion, and time. The model classifies the activities into sleeping, working, cooking, and outdoors. And the random forest-based classifier combined with the feature selection and visualization techniques with accurate predictions and interpretable techniques. And this is like flow of content. Now, introduction is mainly ambition intelligent systems is aimed to provide adaptive and responsive services by predicting user context. And these are like as include multi-sensor data and clans imbalance and the need for interpretability. And the traditional models often lack of transparency, limiting the usability in critical domains like healthcare and assistive technologies. We designed a framework that integrates like pre-processing, feature selection, and random forest classification to predict like usual activities. The mainly like multi-sensor is the input are normalized and evaluated for relevance, while the visualization like KD plots and correlation matrix and the literature surveys mainly we have applied the ambition systems like interaction design in 2022 and the human activity recognition in 2023 and context aware taxonomies 2024 and like ambition assisted living. And this is the mainly the flow of working. Mainly like first is like data pre-processing for scales and standardized like feature data, and second one is feature selection and the identifies and relevant like features of classification, and the main like classification model it predicts the context probabilities using softmax and the optimization, and it minimizes across cross entropy loss beyond gradient distance. Unlike proper probability estimation, it estimate the context probabilities for uncertainty assessment. And the methodology steps like first is normalizing multi-sensor inputs, minimax or a jet score, and encode categorical labels into one-hot vectors. And the features using from information gain or correlation. And the training like random forest model and compute probabilities. And first one is like bar chart of activity distribution, like outdoor dominance, like sleeping, working, and like that. Challenges like classification for also highlights like real world. And the second one is temporal stratification of activities over 24 hours. This is like temporal analysis reveals like outdoor activity dominance across all hours of the day. And the third one is 3D visualization, like 3D scatter plot maps like showing motion, sleeping, working, cooking, and outdoors, like into the context prediction. And the conclusion, like framework effectively predicts user context using multi-sensor inputs and random forest classification, and the high dominance of outdoor activity, while the feature analysis and highlights light and motion as the most discriminative. And the future directions, like including handling data imbalance and advanced sampling, incorporating temporal sequence for dynamic modeling. It's like API style references. Thank you. Any questions, sir?
Yes. Can you elaborate the random forest? What do you mean by the random forest algorithm?
Yes, sir. Random forest means like it is a classification and regression algorithm.
Okay.
And
So your name is Trilok, no?
yeah, sir.
Okay, Trilok, can you tell me what challenge arise when designing machine learning model for context-aware ubiquitous computing environment?
Yeah, sir. Handles large data sets as well as works with both categorical and numerical data, sir.
What type of numerical data you have taken?
Like outdoor multi-sensor data, sir, including noisy like that.
So in what way adaptive machine learning approach improve efficiency, ambient intelligence system?
Yeah, sir. Yeah, yeah. to robust to the outliers and noise for the ambition intelligence, and it reduces the overfitting compared to a single decision tree.
Okay, thank you.
Thank you, Trilok. Moving further, so next we have Adrian Depivin. He's presenting Ampere, a hierarchical multi-agent deep reinforcement learning and evaluation algorithm framework for optimizing smart grid electricity distribution. Adrian, are you there?
Hi everyone, can you hear me?
Yeah, we can hear you. You can share your screen.
Okay, thank you very much.
Yeah.
Hello everyone, I'm Adrian Dipavine and I'll be presenting Ampere, which is a proposed framework for a hierarchical, multi-agent, deep reinforcement learning and evolutionary algorithm framework for optimizing smart grid electricity distribution. And my supervisor in this regard is Dr. Situngu. So as I mentioned, I'm Adrian Dipavine and I'm a computer science student at the University of Johannesburg in South Africa. Now, here's the outline of my system. So this is what I'll be talking about today. And this is the introduction. So what is Ampere? Ampere is a proposed framework, which essentially is an acronym for an autonomous, multi-agent, power efficiency, and reinforcement learning engine. And now I'll describe my problem background. So what is the research question I'm trying to solve? So ultimately, how can hierarchical multi-agent deep reinforcement learning and evolutionary algorithms essentially optimize the distribution of electricity within these smart grids, not only at a regional, but also at a national level, ultimately enhancing smart grid stability and scalability? Now, these are the three main research objectives I've got. So firstly, it's to minimize the surplus electricity generated by a smart home, minimize the electricity deficits required or consumed by a smart home, and then minimize this electricity lost in distribution between smart homes. Now, what is the problem I'm solving and what impact does this have on society? So currently, South Africa's aging grid infrastructure currently faces demand spikes and load shedding, which ultimately has a negative impact on the economy and nation as a whole. Furthermore, these centralized grid networks lose electricity and suffer damages from cable theft. Therefore, I'm proposing Ampere, a framework which aims to utilize this decentralized multi-agent deep reinforcement learning and evolutionary algorithm approaches to ultimately enable society to operate on more resilient grid infrastructure. Now, these are the similar systems I've identified, namely GridLearn, Pacific Northwest, and Elite AI. But here is a research gap analysis matrix I've constructed, and essentially there are 5 characteristics which I'm evaluating the novelty of my solution on. First of all, I'm using multi-agent deep reinforcement learning as I proposed, evolutionary algorithms, which I'll explain shortly. I've got a 3-tier hierarchy of agents, which is not used by anyone else at this moment. I aim to make this transferable between first and third world nations, and I'm using real world data sets. Now, this is the novelty of Ampere. As I mentioned, it's transferable between first and third world nations. I'm using real world IoT time series data sets. I've got a 3-tier hierarchical multi-agent system, and I aim to introduce evolutionary algorithms. Now, this is the experimental setup. So the research methodology I've used in this regard is the design science research methodology. And this is very applicable to Ampere because it essentially uses an artifact, which is essentially the problem I'm solving. And this iterates through this whole framework. And we go back and iterate and improve on this design from feedback from our supervisor. Now, I'm using a real-world IoT Beacon Street dataset, which is essentially real-world sensor data in a time series format from a test hub in Texas, California, and New York. Now, these are the proposed models. So I've got the training, which is 80% of the time series dataset, and this is trained with each agent trained in isolation. Then the test is also in isolation, but only on the 20% of the data set. And then in the simulation, which I'll explain shortly, we've got each agent's prediction propagating up the hierarchy. Now, this is the technology stack I've used. So we've got the front end, Next.js, we've got TypeScript, Fast API, and then in the back end, we've got Python and PostgreSQL. Now, I've got two different types of agents at each smart home. First of all, this is a goal-based agent, and each goal-based agent essentially goes towards maximizing their goal of maximizing rewards or their fitness function for evolutionary algorithms. Now, this is the learning agent, which essentially interacts with the environment, which is the data set, and makes predictions and learns from these predictions in that manner. Now, each agent in the hierarchy communicates through a publish, subscribe design pattern, as shown in this diagram. And I've got a deep neural network, which essentially consists of 5 hidden layers, and each agent is essentially taking in the supply, which is energy generated by a smart home, demand, which is the energy consumed, and distribution, which is how much electricity they are exporting or importing from the smart grid. Now, it's important to note that this is modeled as a reinforcement learning problem with proximal policy optimization, because in simulation in the real world, you want an algorithm that can make predictions without the absence of ground truth. And this is why I've used reinforcement learning and PPO as a gradient-based optimization technique. Now, as a comparative algorithm, I've got several natural evolutionary strategies, which is the evolutionary algorithm, which replaces the stochastic gradient descent of the baseline model and essentially uses a derivative-free optimization technique to update the weights and biases of the network. Now, this is the hierarchy I've been explaining. So at the bottom of the hierarchy, we've got a battery agent, which predicts the state of charge. It then communicates this prediction up to the smart home regional agents at a regional level, which then uses this to predict these features, supply, demand, and distribution, which then propagates this up to a national agent, which predicts the aggregated supply, demand, and distribution in this hierarchy. So I've got a leaky-rally activation function because I've got some normalized features between -1 and 1. The loss function, I'm using MSE. The reward function for the reinforcement learning, which shapes multi-agent behavior, is essentially how can this agent minimize the mean square error. Then the fitness function is similar. How can this fitness be maximized by minimizing this mean square error? Now, these are the preliminary results that I've got after submitting this paper. So this is in order to evaluate the applicability of this framework. So first of all, I will start off with these preliminary results with comparative metrics. Now, this is the benchmark I'm using from this paper. It uses 46 smart homes from the Austin region. It uses an ANN support vector regression and random forest, and they have a benchmark MSE of 0.63. So we would want a value less than this. Now, this is for the Austin
Adrian,
region. Yes.
sorry to interrupt, but your 9 minutes are over. So can you wrap up quickly?
Okay, thank you. So essentially, I've highlighted in green where the predictions are better than the MSE. And in orange, you can just see from testing to simulation how this error propagates up the hierarchy. And this error propagates up the hierarchy mainly for deep learning. Now, what's very good about these evolutionary algorithms is you can see that when we are making predictions up the hierarchy, the MSE stays stable and therefore is applicable in a simulation environment so that the error does not propagate up this hierarchy. But deep learning, as you can see, the error propagates up that hierarchy. So ultimately, Ampere aims to make more resilient grid infrastructure for third world and first world regions, and ultimately make a benefit on society as a whole. And the future work is essentially evaluating more of this proposed Ampere framework, which I have discussed. Thank you. Any questions, please?
Yes, Adrian. So how's the weather in South Africa?
It's very hot, very
Okay, hot.
good for solar energy at the moment.
So
Yeah.
your presentation is also hot. I would like to ask one question.
Yes.
Which AI model you have used and how you test in your simulation?
Sorry, can you please repeat the question? Which AI model have
Yeah.
I used?
Which AI model you have used in your research and how you test in your simulation?
Yes. So which AI model have I used and how have I implemented this in my simulation?
Yes.
Yes. Okay. So essentially, I've used multi-agent deep reinforcement learning and proximal policy optimization for the main AI model, which essentially makes predictions and basically on the time series data. So the agent goes towards minimizing the mean square error, and therefore the rewards are maximized in that regard. And then for the other comparative algorithm, I'm using also multi-agent deep reinforcement learning, but instead of stochastic gradient descent, I'm using an evolutionary algorithm called several natural evolutionary strategies, which essentially updates the weights and biases of the network over and above gradient descent. And as you can see, because of this evolutionary algorithms, the error is a lot more stable in simulation, meaning that when the agents give their predictions up the hierarchy, it's a lot more stable, and the highest level of prediction is a lot more accurate compared to deep learning in simulation, which uses stochastic gradient descent.
Okay, thank you so much, Adrian.
Okay, thank you very much for your time. Thank you.
Thank you, Adrian. Next, we have Jayan V. He's presenting from stress to burnout, effect of misinformation on Indian healthcare professionals during a public health emergency. Jayan, are you there?
Yes, I am.
Okay, sir. You can start your presentation, sir.
Okay. Uh, Good afternoon, everyone. Actually, basically, I'm working in CDAC in Thiruvananthapuram in India. So basically, my research is based on presentation is based on my PhD work, and it has happened during the COVID scenario in 2020. Actually, the state like Kerala is in case of healthcare and also number one in India. So wherein we had faced similar situation uh, previously, wherein we were adequately equipped.
Sir, your presentation is not visible. I think you haven't shared your screen yet.
Yeah, I'm just sharing.
Okay.
Okay.
Yeah,
Is it
it's
visible?
visible. Yeah, you can start.
Yeah. So the scenario is like Kerala was equipped with the uh, all the uh, all the healthcare in terms of equipments and all, so that we were well prepared for that thing before the COVID and all. So and so from there itself, when Nipah was there in Kerala, we had started uh, impacting the healthcare programs with the misinformation that is happening in the social media. So basically, my this presentation is aligned with the impact of social media in the healthcare sector, wherein normally COVID, as everyone know, that it is a kind of disaster, wherein entire sector of uh, people is affected, especially the healthcare professionals. They were usually they have some experience and everything with the dealing with uh, the situation like COVID and all. But still, along with this disaster, the misinformation that had spread over the social media that really impacted not only the public, common citizen, but also the healthcare professionals during this situation. So my topic is basically aligned with this thing. So, during the pandemic, the mental well-being of healthcare professionals often receives inadequate attention because uh, there are they will be situated in a particular point, and they were taking care of the patients, but at the same time they also need to take care of the well-being of their family and friends. So healthcare professionals are more affected, somehow I am saying more, sometimes more affected than the people affected with the COVID and all. So that is why I consider this as a some particular case of attention. So while managing the surge of patients, the psychological toll on frontline workers tend to be overlooked. The COVID-19 pandemic, in particular, has a profound emotional impact on healthcare workers, many of whom experienced trauma, grief, and burnout. Pandemic conditions also lead to heightened burnout due to long work hours, constant exposure to critically ill patients, fear of infection, and even physical or verbal abuse from the public. So there are many situations where the healthcare workers were attacked by some set of people while giving the medicine. Actually, during the COVID-19 scenario and all, the vaccination was there. So there were so many misinformation in social media related to this vaccination and all. So some people are reluctant to take the vaccination. So if in some set of people, when these healthcare workers went on to have this vaccination, uh, there was a huge resistance from that set of people. So even the physically assault also happened during this situation.
Sir, your presentation is not moving, like slides
Yeah,
have been.
yeah. So this research is basically based on the theory. Methodology is basically I done with the it's a kind of uh, it's a kind of qualitative analysis wherein interviewed through online medium, interviewed multiple healthcare workers like doctors, nurses, and all. So, and again, the theoretical foundation is a honeycomb framework. It's normally used to analyze the social media dynamics, consists of 7 interrelated elements. So, as we all know, these are the 7 like sharing, presence, relationships, identity, conversations, reputations, groups. These are common to all the social media platforms. So, everyone,
Sorry to interrupt,
yeah,
Jayan sir.
yeah.
Please come to your research methodology, what you did your work. So come on this slide. Actually, slide
Sure.
is also not moving.
Yeah,
So we have a limited time constraint. So sorry for that.
yeah, sure. So this is a conceptual model we have analyzed for this thing for analysis. So here the model we have basically with the social media ecology. So how the stress factors and the misinformation are dealing in the social media ecology. So we have,
Jayan
yeah,
sir,
yeah,
sorry to interrupt again.
yeah.
You are on only title slide, so your slide is not changing. So please change your slide or
Actually,
which you are
from,
explaining.
from here it is moving. I don't know.
Now it is.
Okay. Uh, Actually, the data collection period spanned in April 25 to April to October 20. In addition to the questionnaire responses, depth qualitative interviews are also conducted remotely with the selected healthcare workers to capture their live experience during the crisis. So prior to participation, actually all the formalities, including taking consents, are all taken. So these are the demographic characteristic of the interview of participants. Uh,
Sir, your 9 minutes are over, so kindly
Yeah.
wrap up.
Okay. So normally, what the situation is like, the entire healthcare sector has been severely impacted due to the misinformation shared on the social media. So to be concluded, so I for the betterment of the better healthcare in the context of social media, we need to strengthen digital literacy, establish verified communication channels, promote fact-checking infrastructure, enable community-led interventions, deploy proactive monitoring by enforcement agencies, protect and empower healthcare workers. So this misinformation is not only a side effect of crisis; it is a crisis in itself. Addressing it requires a coordinated multi-level response that combines technological innovation, regulatory oversight, and grassroots participation. Only then can we ensure that social media remains a force for collective good rather than a source of harm. So, thank you.
Okay, Jayan sir,
Yeah.
so you have data collected during the 2020, na?
Yes, yes.
Okay. So during the corona pandemic,
Yeah.
so what strategy you have implemented to reduce the psychological impact of misinformation on healthcare professional during crisis? So what
Yeah.
strategy you have implemented? Yeah.
Actually, basically, we had we had suggested some basically there is no kind of physical implementation kind of thing. We had, based on our study, we had recommended some suggestions how to tackle the misinformation in the social media. In addition to that, we had analyzed the social media. In addition to the study, we had analyzed the different social media platform like Facebook, Twitter, and all, and done so many sentiment analysis, and the sentiments are from where the exactly the misinformation is coming. We are routing to the channel. So we suggested some AI tools to go to the root of that particular communication, and take suggested the law enforcement agency to take actions on this thing while combining with the technical professionals.
So what do you think misinformation contribute to increase the stress level among the Indian healthcare professional during the public health emergencies? Did you
Yes,
think?
yeah, surely. Actually, what our studies revealed that by analyzing the social media, so there are many kind of agendas flowing along with this particular incident disaster. Whether it is not like healthcare, health emergency, but also other disasters. So people using this particular incident or disaster to propagate their agenda. Say during that all this vaccination and all, people used to say this vaccination is made in this particular country and is targeting against this particular sector of people. So that kind of misinformation really impacts all the social care programs.
Okay, okay, Dr. Jayan, thank you so much.
Yeah, thank you.
Okay.
Thank you, sir. Moving further, up next we have John Paul C. Moshe. He is presenting genetic algorithm-driven parametric optimization for practical torus fully homophobic encryption.
Thank you. Am I audible, sir?
Yeah, you are audible, sir. You can start your presentation.
Is my screen is visible po?
Yeah, it's visible. You can start.
Okay, thank you. It's a great honor to present our research on genetic algorithm-driven parameter optimization for practical torus fully homomorphic encryption. So I am John Paul Corpus Masuhay, and with me is Dr. Reynaldo R. Corpus from Isabela State University, Kawayan campus. So the research overview of this presentation is the introduction, related work, methodology, result and discussion, and the conclusion. So for the introduction, so in today's era where data privacy is paramount, many security algorithms are being developed and tested for their potential. One of those is the fully homomorphic encryption, or the FHE, which provides a solution by allowing computations to be performed directly on encrypted data without the need for decryption, thereby preserving privacy while enabling third-party processing. With this groundbreaking innovation in security,
John Paul, sorry to interrupt. Can you start your video?
yes sir, yes sir. For a while.
Yeah, it is very nice.
Where is my Zoom? Where is my Zoom now? Okay. Okay. Sharing.
Now share your screen also.
So let me continue. With this groundbreaking innovation in security, this paper will simulate the FHE schemes, particularly Torus FHE, to ease the challenges of computational costs during the bootstrapping process and homomorphic operations, which hinder their practical applicability in a real-world setting. Oh, it's not moving. Okay. So this review highlights the rapid evolution of modern cryptography with a focus on advancement in computational power and the growing need for the robust security measures in data handling and transmission. So these are related work composing of literature review and the optimization with genetic algorithms. So among the obstacle in the FHE implemented is the bootstrapping process, which is required to reduce noise in ciphertext, but can be time-consuming, often taking from minutes to hours. So this limitation makes the TFHE less viable for real-world applications. So recent efforts has focused on optimizing the TFHE to reduce bootstrapping time, enhancing the homomorphic operation efficiency, and minimizing ciphertext size. Though this improvement often result in increased computation overhead or greater circuit synthesis or complexity. So the integration of the machine learning and the AI into cryptography has also gained attention. So with the GA, or genetic algorithms, emerging as a promising tool for optimizing complex cryptography systems, so GA are particularly suitable for FHE optimization due to their ability to explore large solution spaces and adapt to various problem representation. So we come up with this conceptual framework, which shows how a GA optimizes the DFHE parameters. So the GA here, guided by a fitness function that considered bootstrapping time, ciphertext size, security level, and encryption accuracy, iteratively refines the FHE parameters. So the FHE parameter are tested in three distinct data sets. We have the text, alphanumeric, and the special character, and suitable and to determine their efficiency and suitability for the resource constrained edge devices. So in the TFHE setup, the TFHE system is initialized with the following parameters seen in the table 1. So the optimization of the TFHE parameter was conducted using a complete ML cryptographic backend to ensure consistency and relevance to the real-world applications. So the following baseline parameters were selected based on standard practices in the cryptographic community and previous work in TFHE system. So these parameters provide a reasonable balance between the security and performance and are widely used in TFHE implementation for benchmarking purposes. While the GA is designed to optimize the FHE parameter by considering 4 key performance metrics as shown in the table 2. So the GA optimizer is implemented using the depth framework, which support multi-objective optimization. So in the genetic algorithm and the TFHE integration, the GA optimization process starts by encoding the main TFHE parameters such as the LWE, or the learning with errors dimension, decomposition level, base, security level in bits mesh unit, and noise parameters into a chromosome structure. The fitness function is designed to optimize multi-objective criteria. So the function ensures that the optimization targets such as bootstrapping time, ciphertext size, encryption accuracy, and security are balanced. So the fitness score for each candidate solution is calculated as a weighted sum of the 4 objectives stated in the given formula. So while the GA parameters are set as shown in the table 3, the GA parameters used in the optimization of TFHE, including population size, generation, and rates for crossover and mutation. So the optimization process is evaluated using a synthetic dataset as shown in the table 4. So the GA for optimizing the TFHE parameters uses a chromosome structure composing of 10 key parameters. So the structure has been validated for accuracy and proper formatting, ensuring its functionality. Each parameter set is evaluated by executing the TFHE operation and measuring performance metrics such as the encryption and decryption times, bootstrapping duration, ciphertext size, and accuracy. So in table 5, baseline performance matrix for the TFHE operations, including encryption, decryption, and homomorphic addition. So these results are then compared to the baseline performance matrix from the previous experiment, which serve as the reference for assessing the effectiveness of the optimization. So the following baseline metrics were recorded during the initial setup and testing of the TFHE, offering a point of comparison for later evaluation. So for the result and discussion, we have 3 items here. And for 4.1, the GA optimization integration result. So the table 6 presents the result of the GA optimization process conducted over 5 generations, focusing on key performance matrix and updates in the TFHE parameters. So each generation represents a new iteration of the GA, with the best fitness score steadily improving across generation, peaking at 0.9691 in generation 4 and 5, indicating effective optimization. So the table tracks various performance metrics, including the
John?
best score. Yes.
Sorry to interrupt, but you're 9 minutes out.
Okay, sir. Thank you. So I will wrap up the result. So in 4.1, shows the bootstrapping time across 5 generations for 3 different data sets. So in these patterns indicate the different type of data have varying performance across data generation, with special characters being significantly slower later generation compared to text and alphanumeric types. So in benchmarking comparison, the GA process resulted in significant improvement across several key parameters of the TFHE, including the LWE, or the learning with errors dimension, was increased from 1024 to 1015 14.02. So it enhanced the security, while the noise standard deviation was reduced from 3.2 to 2.53, and so on. So in edge computing simulation, this table represents the performance metric for TFHE across 3 datasets. It displays the time taken for each operation and the ciphertext for each dataset. And then for the edge computing resource utilization, summarize this table will summarize the resource utilization, particularly in CPU and memory during the TFHE operation. And this study shows that GA can effectively optimize TFHE by decreasing bootstrapping time, reducing the ciphertext size, while keeping high encryption, accuracy, and security. Combining GA with the TFHE provide a promising solution for real-time privacy-preserving computing in edge environment. So that's all. I'm happy to collaborate with you. Here's my contact information if you'd like to keep in touch. Thank you.
So very nice to see you, John Paul.
Yes, sir, from the Philippines.
So my side, one suggestion to you. Your presentation slide is good. Okay, did good
Thank you, sir.
presentation slides. But either reading the whole slide line by line, if you cover only important things and explaining the important thing, it will be very good, because it is look like reading a one by line is very pathetic. So that this is my suggestion from this slide is very good. Okay.
Thank you, sir.
So
Thank you.
this is my suggestion. And my question is that how does a parameter tuning impact computational complexity and scalability in fully homomorphic encryption systems. So how does parameter tuning the impact on the complexity and scalability in homophonic encryption systems?
So,
Do you think this parameter tuning the impact on computational complexity and scalability in encryption system? Yes or no? Do you think
yes, sir, yes, sir.
the parameter which you're using for tuning the impact computational complexity and scalability in homomorphic encryption system?
Yes, sir, yes, sir.
So how does your parameter tuning this complexity? Can you elaborate?
Basically, I'm basing with the cited paper, sir. That is my benchmark. I pattern my parameter with the existing baseline given by the other researchers.
So please, in future, read out this key what parameter you impact on complexity, you know? Okay. So this is my suggestion to also go through this the parameter which impact on the complexity and scalability in a encryption system, right?
Yes, sir.
So this is my suggestion. So please go through this topic also to cover your entire presentation, what data set you have taken. So please go through this. Okay. Thank you so much from my side.
Noted, sir. Noted. Thank you, sir.
Okay. Okay.
Thank you, sir. Next, we have Alpa R. Barad. She is presenting grass quality analysis with unsupervised Gabor K means plus plus and advanced Gabor denying technique. Alpa, are you there? Miss Alpa? I can see. I think you are on mute. Alpa? I think her network, she has some network issue. Okay, we'll move forward. Next, we have Trilok Kola. He's presenting pattern discovery in genomic sequence using advanced data mining algorithms. Trilok?
Yeah, sir. Yeah.
Yeah, you can start with your presentation.
Pattern discovery in genomic sequences using advanced data mining. Now, abstractly, this work investigates with advanced data mining algorithms for discovering patterns and what fits in genomic sequences using k-mer analysis. By applying a priori based frequent pattern mining and principal component analysis and sequence logo style visualization, conserved mod fits and structural features are effectively identified. Now, introduction is the spatial exponential growth of genomic data requires scalable computational methods to extract the meaningful biological insights. The traditional bioinformatics approaches struggle with high throughput datasets, making advanced data mining essential. Techniques such as schema decomposition and motif discovery and dimensionality reduction, which is enable to automatic identification of conserved patterns and regulatory analysis signals, and which is like this is a literature survey recent studies with the integration of AI and data mining in genomic analysis in 2022 applied intelligence systems for COVID-19, and while with the genomic sequencing and mutation detection. And 2023 demonstrated with cancer prediction through clustering and classification. And 2024 a hybrid optimization method for motif recognition. And 2025 a benchmark with machine learning models for DNA sequence analysis. Collectively, these work emphasize the growing of importance of mutational tools for pattern discovery in biological data. And the methodology. This is the first one is data pre-processing, extracts local using k-mers, and the feature construction constructs feature matrix of normalized k-mer frequencies. And the feature selection retains top features with highest variance. And the dimensionality reduction reduces dimensions using PCA. And the pattern discovery Y means discovers frequent item sets and association groups. And the motif localization maps frequency of motif along with sequence positions. And the sequence logo visualizes the nucleotide probability distributions across positions. And the results and discussion. First one is top 10 most frequent gamers, with quantifying the dominant of trinucleotide motifs, each exceeding a frequency threshold of 80, and indicating conservative with sequence pattern. And the second one is like 2D PCA of sequence vectors derived from K-mer compositions, illustrating variance driven clustering in reduced dimensional space. This one is like stacked bar chart visualization of nucleotide pa- proportions across motif positions, simulating sequence logo entropy and the base conversion. This one is three-dimensional PCA of K-mer encoded sequences capturing structural diversity and latent grouping in genomic data. Conclusion is successfully developed a comprehensive framework for genomic pattern discovery using K-mer analysis, a priori mining, and PCA. The future work will focus on scaling the approach of larger dataset and validating discovered motifs against the curated biological databases to enhance interpretability and clinical relevance. These are the APS style references. And thank you.
So, 3 log. Okay.
Yeah, sir.
So my presentation, okay. My suggestion is to improve some presentation slide, right? So presentation of the slide is little bit maybe good. Okay.
Yeah, sir.
So what type of data set you have taken?
So this is genomic data set. Genomic data set.
Okay. So what can you elaborate the K-mer analysis which you show in your slides?
Yeah, sir.
You have used the K-mer analysis. So can you elaborate?
Yeah, sir.
Please.
So it is like K-mer is a subsequence of length K obtained from a long DNA, RNA, or protein sequence. For example, if you have the DNA sequence, the three mers means like ATC, TCG, and CGT. The first one is K-mer analysis means studying the frequency, distribution, and patterns of these subsequence with biological data.
And what is nucleotide proposition?
So it's for genomic assembly and metagenomics and spatial classification. It's like identify the mutations, repeats, or errors, sir.
So what can you give the name of the algorithm which are using the data mining for
A priori
discovering the
mining.
genome sequence?
A priori mining, sir. A priori mining.
Okay, thank you so much. Thank you from my side.
Thank you, Darilok. Okay. So I think Alpa is here now. So let's move with her presentation. Let me share my screen. Yeah. So she is presenting grass quality analysis with unsupervised Gabber K-means plus and advanced Gabber design techniques.
Hello everyone.
Yeah, Alva, you
My
can share your
yeah,
screen.
yeah. Good afternoon everyone. My name is Alpa Bard and I am presenting my research paper is grass quality analysis with unsupervised Gabor K-means plus and advanced Gabor denoising techniques. So these are the points which are I have to cover. First, research contribution, introduction, methodology, result analysis of proposed study, and analysis of outcome. My objective is my research is that the animal feed is when animal feed is supplied and reach to the destination, at that time the quality of freshness is not good as when feed is cut. So problem is that the fresh grass is not demanding of fresh grass increases, but the fresh grass is not reach at the destination. So for that solution, we have used median and denoising filter for input images and Gabor filter with K-means plus model. So, as we know that in particularly India, we are very much about tea and coffee. So we are for fond of milk. So and the feed like cattle, cow, they are feeding green leaves. So the demand of animal feed is increasing day by day. But the problem is that when we supply animal feed, then at that time they are fresh, but after some time, approximately 1 or 2 hour, after 1 or 2 hour, so they are not fresh as much as they when they are cut. So the problem is that if we we cannot analyze or monitor the freshness of graph. We have to monitor by manually, while checking the grass and checking the quality of grass by seeing by our observation. So the point is that if we eat not fresh grass to the animal, then the health of animal feed is not so good, and indirectly they are affected to population, because if we are consume their milk or a milk product, then indirectly they are affected to people's health. So in our proposed study, we are using unsupervised algorithm, which is K-means plus, and using the Gabor filter. So first of all, we are sending the input images, and after that, we using denoising technique. They remove the noise, unwanted noise in the images. After Gabor filter, the work of Gabor filter is that it is used for texture analysis and image extraction. So after Gabor filter, we use K-means plus, which is used for RGB, and at that time it checks the quality of grass. So the how they check the, and I've used K-means plus because it select the initial centroidness very carefully, so that K-means plus use the better clustering, so we can get the better value for RGB, and using that RGB we can decide the threshold that which are the grass is fresh or not, because we have to check the grass quality, that grass is fresh or not. So we have to make sure that the algorithm of K-means plus decide the ranges of RGB accordingly. So it carefully select the centroid. So clustering is improve using centroid. So K-means plus has a fast convergence of clustering and a stable result. So this is the sample data that we have. First image is a good images, which is very fresh. After some time, it is same image is taken as a mild, means average image, and after it is very poor image. It means that the when time is passed, then the quality of grass is surpassed. It means it degraded. Here we have used the different filter using we apply the different filter and take the data. We have used the mean square error, PSN and SSI, different matrices, which is used in good, moderate, and poor conditions. So that are the using that are the filter, yeah, like a median filter and fast denoising filter. So that are the different results we have get that using different matrices. This is the segmentation analysis of proposed model. It means that we have select different centroid, like we have select 2 centroid, after 5 10 centroid, and after 9 centroid, because it is up to us that how much centroid we have taken for checking the result. These are the result of proposed study that first of all, if we are don't using denoising technique, and we have take the cluster equals to 2, cluster 5, cluster 10, and cluster 20. So that are the different results we have get without denoising technique. So the 48.07, 52.15, that are the result we have get. If we are using denoising technique, then this 54.18 continuously, that are the result we have we get and without Gabor filter. If we are using without Gabor filter, then the cluster 2 say to cluster 20, this type of result we get. And if we use the with Gabor filter technique, so that are the result we are means 71.08 to 79.86, that are what type of accuracy we are getting. So yeah, here we changed the different cluster size, and the variation of different cluster size, so that are the result we have get. So if you using the Gabor filter, which improve the performance of K-means algorithm by 9.18, and all over proposed study, the accuracy get is 79.86. So uh, the limitation is that this algorithm, it is used for only for grass forage. For future purpose, we can extend to other cattle food also, and we can also use the different algorithm like convolution learning integrity, and as well as IoT integrated framework. So it give us the real time information of cattle forage. Thank you.
And please go to the your last slide.
Conclusion.
Yes, yes. So, after listening of your whole presentation, concluded that the Gabor filter is very essential part of your research. So, what are the role of Gabor filter to improve the quality, na? And how you calculate the accuracy? Yes, you say that
um
79% is accurate. So, how you calculate the accuracy, and what role of the Gabor filter to improve the quality?
the main work of Gabor filter is texture analysis. It gives a texture analysis as well as image extraction. So when we go through the first part, so it is when input image is come, then we are using denoising technique, and after that denoising technique we are using Gabor filter. So Gabor filter work is to texture analysis, and after that texture analysis, we this input image is input is we are data is going to the K-means clustering.
So, you use the image processing.
Yes, sir.
Okay, so how you take a you mentioned in your presentation there is some threshold value, na? So how
Yes.
you take the threshold value to find the grass, to find the grass is fresh or not? So how you taken the
I,
value of threshold?
yes, sir. Yes, yes. First of all, these are the green images, like color images. So we have to find the RGB range. So I have number of images. I have the thousands of images I have. So
So
I have taken
how you taken these images from which data set?
Actually, sir, we have a farmhouse and we are supplier to a company in Jamnagar. So we are
Okay, so you are
supplied.
having your live, so you can.
Yes, yes, I have a farmhouse. We are supplying this.
Jamnagar means you are residing in the Gujarat.
Yes, yes, sir. We are supplying in Reliance
Okay,
because
you are supplying.
Vantara is there. Yeah, we are currently supplying green grass to the Vantara.
So
So
okay, so you are living in the Gujarat, na?
yeah,
So
yes. In
મને
Jamnagar.
બધી ગુજરાતી આવડતી છે મેમ.
Okay.
Okay, you can explain. Okay,
Okay.
okay. I worked
So
4 years in Gujarat, so that's why.
okay, sir. In
Okay.
which city, sir?
Surat, ma'am.
Okay, okay, sir. So,
Yeah,
sir,
continue.
this is a current and this is up to our business because in our business there is a one problem is occur which is about quality problem, grass quality. Because whenever we are sending grass, so they are rejected because they tell that the animal feed is not fresh, because the time when time is passed, the freshness of animal feed and greenness of feed is decreases. So they are that's why I have decided that I will work on this.
Okay, nice. This is your real-time problem is very good.
Yeah,
So,
real time problem.
So you can also file the patent for some, if you have any some claims, so also file the patent. This is my suggestion for you. Okay.
Yes,
Otherwise, it's
okay.
a good data set. Thank you. Thank you so much.
Okay, thank you. Okay, thank you.
Thank you, ma'am. Thank you, sir.
Thank you, sir.
Yeah, moving next. So up next we have Zlantika Kovachevi. She is presenting project-based learning, comparing the results of group and individual projects in undergraduate program of information system. Zlantika ma'am, are you there?
Yes.
Yeah, you can share your screen.
Do you see my screen?
No, ma'am.
No?
No, can you try again?
Because I shared.
Yes, seen,
and
seen.
You see now?
Yeah, yes, ma'am.
Okay. All of us are from Sofia, Bulgaria, and from the Institute of Mathematics and Informatics of Bulgarian Academy of Sciences, from the University of Sofia, and from the University of Mining and Geology. The aim of the study is to compare the results of group and individual projects of undergraduate students studying information systems. The research is based on statistical inference and hypothesis test. A hypothesis test is presented regarding a difference between means of two dependent samples for quantitative indicators that have a normal distribution. The result analysis is based on 3 years experiments with students' projects. For all experiments, the null hypothesis is rejected, and in both methods of assessment, different results are obtained. Researchers have examined students' context-dependent learning preferences. The desire to learn with one or another classmate depends on the subject matter, the learning style, the participants in the group, and other factors. Group assessment is a widely used method which emphasizes collaboration between students. Group work can stimulate students to obtain many skills, which will be useful in their future professional positions. Collaborative group work has a positive impact on the student educational process to improve student responsibility and learning. It has been proven to develop a multitude of skills, including
Sorry to
teamwork.
interrupt, ma'am. Actually,
Yes?
please reshare your screen again. Your presentation, please.
I didn't understand. You don't see my screen?
Yeah, it's visible actually. So are you able to see the screen or not?
I see the screen, yes.
Yeah, no, I'm able to see, but I think Firdaus sir.
Okay, now is it okay?
Okay. Yeah, it's visible now. Ma'am, you can continue.
Continue.
Yes.
Just ma'am, just one second, one thing. Just present it in the presentation mode.
Now it's okay?
Yeah, it's okay, fine. You can continue. Sorry to interrupt.
Okay. Collaborative group work has a positive impact on the student educational process to improve student responsibility and learning, especially to develop skills like teamwork, empathy, communication, conflict resolution, self-management, and leadership. Compared to individual learning, the group approach leads to higher quality learning, understanding the subject content, higher confidence, more creativity, persistence, and greater student satisfaction. One of the very important aspects of group work is the way of students grouping. It is possible to be done homogeneously or heterogeneously. Some researchers recommend forming groups independently by students, as this contributes to better students' attributes and outcomes. According to other studies, the formation of heterogeneous groups by the teacher is preferable because it increases the quality of learning. In heterogeneous groups, students have different abilities, skills, achievement levels, and cultural and social backgrounds, and they can complement each other. This synergetic diversity is not available in homogeneous groups. Recent studies show that highly capable students prefer group work over individual work when they have the opportunity to work with students of similar capacity, to choose the assessment topics, and when all group members make an equal effort. A study outlines the following common obstacles to effective collaboration. The first one is lack of collaboration skills, such as accepting opposing views, providing detailed explanations, giving and receiving help, and negotiating. The second is free riding. It means that some people contribute the most, others work less, and some do not even put any effort to complete their tasks. The next is competence status. Not all students have equal opportunities to express their opinions and contribute fully to the completion of group tasks. As students with perceived higher status take a leadership role and ignore the opinions of the others. And the last is friendship. Sometimes friendly feeling masks the lack of activity of some students, as well as contribute to the lack of active debate and opposition to different opinions. The research method. We use hypothesis testing, which involves assessing the extent to which a predetermined parameter value is plausible to conclude whether the information obtained from the sample corresponding expectations. In this way, a decision can be made about accepting or rejecting the hypothesis based on the results of the observations. The research in this paper is conducted through statistical inference and hypothesis. The term hypothesis in the context of statistical inference is usually defined as an assumption about the value of one parameter or several parameters of the sample space. The null or working hypothesis claims that there is no statistically reliable difference in the compared statistical indicators in the general population. And the alternative hypothesis claims that the observed difference in the samples is statistically reliable and can be generalized to the general population. In this article, a hypothesis test is presented regarding a difference between means of two dependent samples for quantitative indicators that have normal distribution. Students' t-test for dependent samples is applied. Here, student is the name of the author of the test. In this paper, we explore results from the project work of students enrolled in the Information System Analysis and Design course in the Undergraduate Information Systems program of Sofia University. At the beginning of the course, students organize themselves into teams with approximately the same number of members. Depending on the size of the course, the number of students in one group varies from 8 to 11. The teams start working on the project about a month after the course has started, so they have 10 weeks to complete the projects. The assignments could be divided into two categories, team assignments and individual assignments. Data from 3 years is used for the experiment. The first course was provided in 2019, the second course in 2022, when the education was mixed, distant, and present in the class due to the COVID-19 crisis. In the third course, provided in 2024, the education was present.
Ma'am, sorry to interrupt, but your time is about to end. So can you
Okay. Then I will go to the results. Here you can see the results of t-tests for full-time students in these 3 years. As you see from all the tables, the empirical values are less than critical values of the test. Critical values are taken from a table of students, which means that we reject the null hypothesis and we suppose that in both cases the results are different. Both cases, I mean project, group project and individual project. In the next 3 tables, we present average marks on the individual project compared to the marks of the group project. It is seen that in most of the groups, the marks of individual project are less than the marks of group project. Only there are some exemptions which are highlighted. As a conclusion, we can see that the results of the present study demonstrate that in general, students perform better in developing a group project compared to an individual project. The results are stable and they are not affected by the form of education, in person or online. The advantages of group work in the learning process mentioned in this article, enhanced problem solving, peer support, and shared responsibility are reflected in the result obtained. The conclusions drawn support the thesis of developing students' group projects as effective preparation for their future professional realization. As a conclusion, we can recommend applying both methods, group and individual project, for students' assessment, paying attention to their advantages and disadvantages. While the course discussed is a part of information systems and it is IS-specific, the proposed pedagogical framework shows promise for broader application. It is easily adaptable to other disciplines and university programs. Thank you for your attention. You can see here references.
Thank you so much. No question from my side.
Thank you, ma'am.
Sir, how many left presenter?
So, sir, we have 3 more presentations.
Okay.
Yeah. So up next we have Gwen Hong Ka. He is presenting a robust face recognition system using stable diffusion and synthetic data. Gwen, are you there? Gwen, you are not audible. Your mic is unmute, but still we are not able to hear you. Gwen? So are you there? Okay, I think Gwen have some technical issue. We'll move further. Next we have Keshan Tudani. He's presenting Stock Vision X, leveraging financial news sentiment and technical indicators for stock movement predictions. Keshav sir, are you there?
Yes, sir.
Yes, sir, you can start your presentation.
Good afternoon, everyone. I'm Keshav Dudani, and today I'll be presenting a work titled Stock Vision X, predicting stock movements with sentiment and technical indicators. This is a joint research contribution from KIT Deemed University and IIM Visakhapatnam. Let's get started. So, stock market is one of the most volatile system in the world, influenced not only by technical indicators like price or volume, but also by investors' psychology, news headlines, and global events. Traditional models such as Arima and Gauge assume stable patterns but break down in turbulent conditions. This creates a research gap. How do we design a framework that is lightweight, interpretable, and combines both quantitative and qualitative signals? There's where our proposed model Stock Vision X comes in. Our study was guided by three objectives. First, to integrate financial news sentiment with historical stock data. Second, to build a hybrid model uh, called Stock Vision X that fuses these approach, naive bias for sentimental classification, profit for time series forecasting, and rich classifier for final prediction. Let me briefly touch on related works. Uh, every models, early models like AFZ in text in 2009 attempted to link sentiment with stock movement but achieved very low accuracy. Uh, in 2014, ANNs showed promise, but they required huge data for training. Social media based models struggled with noisy and sarcastic data. Deep learning models like CNN and LSTM, they showed higher accuracy, but the computational cost and the GPU requirements were very high. And recent transformer-based models like Fin GPT and Bloomberg GPT, they emerged along with reinforcement learning approaches. The research gap was very clear that either the models are too simple or too heavy, uh, and, and they lack the effective integration between sentiment and technical indicators. Our goal was to find a middle ground. Uh, this is the methodology that we implemented. Our model was a three-layer framework. Step one used naive bias, that classifier that was trained on over 6,000 financial news articles from sources like Reuters, Bloomberg, or the Wall Street Journal. These articles were classified as positive, negative, or with neutral sentiment. Step two applied profit, a forecasting tool from Facebook, to historical stock data from Apple, Tesla, and Amazon between 2024 and 2022. Along with prices and volume, we engineered key indicators like moving average, RSI, and MACD. Finally,
Keshav, could you please on your video also?
yes, just a second. Hello.
Yeah, now.
Uh, should I continue?
Yes, please.
Finally, step 3 uses a rich classifier to combine sentimental and historical trend data to convert, which is then converted into a binary prediction, that is whether the stock price will increase or decrease. Rich was chosen for its efficiency to avoid overfitting. Uh, Experimental setup. For our experiment, we used 80-20 test train split and 5-fold cross validation. We tuned the ridge regularization parameter following alpha equal to 0.001, which gave the best results. We also compared our model with 11 established models like regression, MLP, SVM, uh, logistic, random forest gradient boost, LSTM, and etc. In all these experiments, were implemented in Python using libraries from scikit-learn and Profit with data sourced from Yahoo Finance. In terms of accuracy, StockVision X achieved 87.5% accuracy on Apple, 86.3% on Tesla, and 85% on Amazon. The F1 scores were equally strong, ranging between 0.85 to 0.874. And our sentiment classifier achieved an accuracy of 91% on financial news. Importantly, precision and recall were also well balanced, which means our model can identify both upwards and downwards trend reliably. For example, in Apple's case, recall was 87.7%, and when we compared our models to benchmark models like StockVision X outperforms all those models. To illustrate, I have given a diagram on how LSTM, ARIMA, and Profit and XGBoost correctly identified or misclassified the data points. Video. By contrast, StockVision X delivered up to 87.4% on Apple, representing a significant improvement. This demonstrates the value of integrating sentiment with technical forecasting. First, so the question is, why does StockVision X works? First, news sentiments captures investor psychology, optimism, and pessimism, which directly drive markets moves but are invisible to technical indicators. Second, Profit effectively models seasonality and trends in stock data. And third, the rich classifier ensures project robust predictions while keeping models lightweight and efficient. Together, this balances accuracy and efficiency and makes StockVision X practical for real-time trading applications. So there were some challenges because our application was limited to only 3 technical stocks of Apple, Tesla, and Amazon. Also, the application of our stock vision X models are very much vast, and we plan to expand to multi-asset global data sets and also incorporate advanced transformers based models like Finbert and develop real-time streaming systems. We also see potential in reinforcement learning approaches for making trading decisions. In conclusion, we proposed Stock Vision X, a hybrid framework that combines financial news, sentiment, technical indicators, and time series forecasting. Our model achieved more than 87.87% accuracy across Apple, Tesla, and Amazon consistently. Uh, so that's all. Thank you.
Okay, Keshav.
Yes, sir.
So, for which type of stocks or market condition is the stock vision access approach most and least effective?
It is most effective for stocks which are traded in high volumes and which are directly affected by uh, sentiments of the buyers. And it is not, and its application is not limited to some stocks. It is applicable for every stock because every company is driven by some emotion of the proprietor and the investors. So it is not limited to only Apple, Amazon, Tesla, Google, Microsoft, not just big names, but also to very like non-popular stocks like let's say Coal India. That's
So, how you calculate the validation accuracy?
uh, validation accuracy. Uh, I did it.
Brief in
It's
short,
this.
in
This is the validation curve. Is the a diagram visible to you, which I'm
yes,
trying
yes.
to show? Share.
Can you answer?
I, I am talking, this is the validation curve that we achieved.
Can you explain in one line?
Sorry.
Can you explain?
And I can't actually get your question. What are you trying to ask?
My question is very simple. Ki you are calculating the F1 score and validation. No? So can you brief in one line ki how you calculate all these parameters?
We use mathematics to calculate all these from like precision is like true positive divided by all, true positive, false negative, and these four
Okay,
variables.
go through this in a detail. Okay, thank you so much.
Thank you, sir.
Okay.
Thank you, Keshav.
Can you hear me?
Yeah, Gwen.
Yeah, okay. Um,
Yeah, you can go with your presentation.
you can see my screen?
Yeah, we can.
Okay. Okay, I'm start. Graph phase recognition system using stable diffusion and synthetic data. And our paper is 803. First one, I will introduce about our report model. First one, we reside our data to 512 as 512. Then we'll give it to LoRa Python table diffusion. I use LoRa Python table diffusion to get the identify specific feature of the image. Then we give it to generate the synthetic image more than 15 image. and we use it to merge with the real data sets, and we split it to 70% for chain and 20% for evaluate and 10% for telling. And last one is we change with YOLO VAN classification. So next one, we talk about LoRa fine tuning. First one, we have pre-chain wave. Then we love with LoRa is a BNA. Then after chain, we have the merge wave. That is LoRa fine tuning. Next one, you can see that is a normal synthetic image, and then we use the LoRa feature to generate more than 50 images. So we get the image after you the synthetic image generation. Next one is we also use the real data sets. That is flow of real data sets. First one we have the original image. Then we use it to generate a synthetic image, and we also add the noise to image. We use a Rosa noise. And last one is change with YOLO VA. Next one, this is experimental result. First one is online data set. We use the YOLO VAN, and top one accuracy is 16%, and top five is 92.67%. And also with our methods, we 80% of top one accuracy, and we also better than top five is the real one. And so the overall, our model better than 20% of total. And in the real data sets, we also better than our their model a little bit. You can see. Next one, we also have the training and evaluation process. You can see we have the right one, the left one is the baseline is real only, and the left one is our repo methods. You can see. And in the future work, we incorporated identity aware losses and improved the synthetic image quality and realistic. And we also explored alternative personalization methods, and we enhance the robustness to noise and real world variation, and also synthetic data augmentation pipeline, and also evaluation relation on broader and more diverse data sets, optional end-to-end pipeline for development. So that is all our my presentation. Thank you for your listening.
There any specific limitation of face when we taken the face data sets? There are some limitations.
Limitation of get the data sets.
Yeah.
We have the limitation is the data set if just have the one image. You know, like I just capture one page size of the person, so we just get the same image. So we that is how we have to use the synthetic image to our datasets. That is the limitation of our repos.
Okay, thank you so much.
Yeah, thank you.
Thank you, Gwen. Up next, we have, and this will be the last presentation for this session, Trilok Kola. He is presenting temporal pattern recognition in IoT sensor streams using spatiotemporal reasoning. Trilok?
Yeah, sir. Yeah.
Yeah, you can start.
Yeah. Good afternoon. Temporal pattern recognition in IoT sensor streams using spatiotemporal reasoning. This study presents a framework for recognizing temporal patterns in IoT sensor data using spatiotemporal reasoning. By integrating statistical modeling, anomaly detection, and visualization identifies both localized anomalies and long-term environmental trends. Now, the introduction is IoT devices generate the massive spatiotemporal data streams that reflect real-world dynamics. The traditional models often ignore inter-sensor dependencies, are sensitive to noise, and the lack transparency in real-time detection. Effective recognition of temporal patterns and anomalies remains a key challenge. Our framework integrates statistical descriptors, kernel density estimation, correlation metrics, and spatiotemporal visualizations. The literature survey existing work using event logic graphs, spatiotemporal convolutional networks, semantic reasoning, and reinforcement learning for IoT anomaly detection, while effective of most approaches compromise interpretability. This is the methodology framework. First one is like data pre-processing. In the data pre-processing, temporal alignment and normalization. Next one is feature selection, statistical features, temporal derivatives, and frequency features. And the input data, multivariate sensor stream, and the spatiotemporal coordinates. And the probability density modeling, here we kernel density estimation and Gaussian distribution. And the anomaly detection, binary classifier anomaly score. And the spatio-temporal correlation modeling, here like temporal correlation matrix, spatial weighting, and spatio-temporal coupling. And the spatio-temporal visualization mapping like 3D scatter plots, wire plots, and 2D heat maps. And the methodology step, the pre-process of sensor data like alignment, interpolation, and normalization. And the extract features, mean, variance, derivatives, and Fourier components. And the spatio-temporal dependence, correlation plus spatial weighting. And the detecting anomalies using classifiers and IQR thresholds. The first one is like sensor readings with anomaly detection. Here like multivariate temporal rays with anomaly makers. It's like, for example, one sensor showed a sharp deviation near moon, and the highlighting the localized irregularity multivariate makes anomaly detection like transparent and actionable. And here, like density, first one is like the kernel density overlays reading. It's like temperature value shows like 21 to 24 degrees Celsius while fitted with Gaussian models. And next one is like histogram with Gaussian distribution, which is like 22.3. These analyses capture the central tendencies and deviations for environmental monitoring. Here, like first one is like sensor to sensor correlation matrix, and here intersensor coherence with the most sensors strongly correlated with S4 shows in like isolations, and the 3D is like reveal thermal gradients and anomaly propagation like across sensor in time and space. And the conclusion, like it's combined the spatio-temporal reasoning with statistical and visualization techniques with interpretable IoT monitoring. It effectively identifies localized anomalies and global patterns. And the future research will extend with like deep learning for adaptive modeling, integration with knowledge graphs like semantic reasoning, and deployment across heterogeneous IoT networks for more resilient and explainable monitoring. This is like references. Thank you.
So am I audible to you?
Yes, sir. You are audible.
I think this is your second paper, na?
Third paper, sir.
Third paper.
Yeah.
Okay. So last time we discussed with the K-MERN analysis of your
Yeah,
research.
sir.
Yes. So my question is that how does your proposed model represent the integrate the spatial relationship between the IoT sensor to improve the accuracy of temporal pattern recognition? So how does the proposed model?
Yeah, we propose like 10, sir. Top 10 like S0 starting with S0 and S10. Like that we use it like that stacked bar like temporal like multivariate data set, multivariate plot. Instead of that, we use it like a 2D, like a sensor to sensor, like that we use it, like 2D heat maps. Here we use it like KD curves. It's a proposed model is like a Gaussian distribution, sir, which is like all like spatio-temporal using with IoT plus and Gaussian distribution, like that we use.
So what specific algorithm was used to identify the sharp temperature deviation near the noon, and how was the threshold for irregularity determined?
So here mainly we using detecting anomalies using classifiers mainly, and model like spatial temporal dependence plus spatial weighting plus correlation. This is the actual model. Spatial temporal dependence. It's like with the spatial weighting plus correlation.
Okay, thank you so much from my side.
Thank you, sir.
Thank you, Trilok.
Thanks.
I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for your support during the fourth version and all previous 3 versions of the conference. We will be happy to have you in the 5th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ISBM 2025. I also thank our session chair, Dr. Firdaus Sheikh. A small token
Thank you
of
so much, Siddesh.
a small token of appreciation on behalf of Team ISBM 2025 and Global Knowledge Research Foundation and partners.
Okay,
Sir,
thank
do
you
you
so
have
much,
any
Siddesh. Yes, yes.
global?
please.
So, do you have any closing remarks for the participants?
Yeah. So first of all, I would like to thanks for participating in the fantastic conference, which is our 4th World Conference or Information System for Business Management. And all presenters are doing very well, and they present all paper, and this is very appreciable. Ki all papers are quality papers, and they are presenting with the data set, with the proof, and it is very remarkable. And I congratulate all of you for your publication, and it is very nice for GR collaboration with the GR Foundation and collaboration with the Springer, and wish you all the very best, and thank you so much.
Thank you, sir. I would request everyone to switch on their cameras so that we can have a snapshot of the meeting. Yeah. Okay. Do they have a snapshot? Okay. Thank you, everyone. Have a good day.
Thank you.